Alright guys, in this video presentation we're going to be talking about angles from section 1.4 and so let's get this video started with the PowerPoint slide, okay? Um, and here is an interesting graphic just depicting some of angles that pilots would need to know, okay? If anyone would ever move on to becoming a pilot, it's very detailed training, as you might well imagine, but there's these angles called yaw and pitch and roll, okay? So you can always look them up if you have interest, but I thought it was a neat little graphic, so they'll get us a little presentation on angles, okay? Now, in any angle, okay, the way we define an angle is that it is, okay, the union of two rays, or two rays coming together. Now, I know actually these are showing as segments, but again, a ray would extend forever. But two rays or two segments with a common endpoint, okay? In this case, we have ray AB, or I'm sorry, segment AB, or ray BA and ray BC, joined together at point B, which is called the vertex. So the vertex is pretty much how we're going to name the angle, okay? So angles can be named in a couple different ways. I could refer to this as angle B, and it would be pretty much identified because it's basically the only angle depicted there. I could identify it as angle 1, okay? I could identify it as angle ABC or CBA. So there's three ways of naming an angle. Actually, four, if we're naming it with the letters, then the middle letter has got to be the vertex. We could name it with the vertex alone, or we could name it numerically, okay? So, and in this case, we're saying that this is a 49-degree angle. So we write the statement, the measure, M is for measure of angle ABC, 49 degrees, measure of angle B is 49, measure of angle 1 is 49, or CBA, another alternate way of naming that angle. Four alternate ways of naming that angle. Which is best really doesn't matter, depends on the situation, but referencing any one of these, it should be understood that the angle in question is the one that is shown there, okay? Naming angles usually is in degrees. Next year, Algebra 2, you'll talk about naming angles in radian measure, okay, not to be worried about now, okay? Estimating angles, you should be able to kind of spot estimate things like 90, a 60, a 30, and a 45, okay? You should be able to get a rough estimate of what those angle sizes look like, okay? Obviously, 90 is perpendicular, and of course half of that, and then maybe a third of that is 30. You should be able to eyeball estimate. Now, smaller angles are interesting, okay? To say that if you stick your hand out and hold up your thumb at arm's length, then the lines or the angles formed by the rays of light coming from the fingertips, your thumb tips there, back to your eye, will form a 1-degree angle. And interestingly enough, that 1-degree angle is said to be the 1 degree of arc that the moon and the sun subtend in the sky. In other words, holding your thumb out at arm's length, you should be able to block out the sun or the moon, saying that that's 1 degree, okay? 20 degrees would be your outstretched hand, as shown here, okay, at arm's length, okay? This kind of interesting facts, okay? Obviously, we should know name classifications of angles, okay? Acute, less than 90, right, equaling 90, obtuse, greater than 90, but less than 180, and straight, of course, being opposite rays or a line, 180-degree angle, okay? So another definition of a straight angle is, again, opposite rays or a line, okay? The angle addition postulate, much like what we saw with segment addition, okay? If we want to split an angle into different parts, then we take a point somewhere inside of the angle. It's an interior point, and we draw a ray from the vertex to that interior point. So we start off with angle ABC, the all-inclusive. We take the interior point D and we form a ray. Okay, so now what we have is actually we have three angles. And here's where the angle classification comes up handy, because I can't refer to angle B because angle B could be one of three angles. So really I have to refer to these angles as depicted here using the three-letter classification. That would be angle ABD, angle DBC, and the all-inclusive angle ABC. So when you name it with the three letters, your eye should be tracing out that angle, okay? Now the angle addition postulate says whatever the measure of ABD, and this is typed wrong, so that should be corrected. Make sure you correct it. ABD, ABD plus angle DBC is equal to the all-inclusive angle ABC. Okay. Here is another another statement of the angle addition. Okay. It simply says, okay, that the measure of these two angles coming together will add up to the all-inclusive angle. Okay. So if we look at this picture here, we give you some values. AOC, you trace it out. AOC, that's the all-inclusive angle. Said to be 120 degrees. BOC, you trace it out as 75. Okay. So we're looking to find the measure of angle AOB, the missing angle. So we can set up the angle addition postulate as stated here. Angle AOB plus BOC is equal to angle COA. Fill in the missing pieces, solve for the unknown. Okay? Come down here. Here's another problem here. Find the missing angle. Okay? From what we're showing here, okay, the 53-degree sweep here is angle DAC. DAC is the 53. The 64 is the all-inclusive. The 64 is the all-inclusive. So what you want to find is the measure of angle CAB, okay? Which of course you can find by saying, okay, yeah, 53 plus what is 64? Well, then that has to be an 11-degree angle. Likewise over here, okay? The way this is marked off, and you'll see it, okay? There's the one sweep, the one arc sweep, which is identifying the smaller angle. That is the angle NLP. NLP is identified as 95 degrees. 153 is the entire angle MLP, which would be 153. If we're looking to find MLN, then it would be 153 minus 95 would be the angle MLN. So that would be 153 minus 95, which would be, what, 58 degrees for the missing angle there. Okay? Here's some algebra that goes along with angle addition postulate stuff. Okay? So, sorry, let's get back to that. Okay? Here's an example here. It says angle 1. This is where multiple angles are sometimes easier to name with numbers. 1 and 2 kind of reference, and it helps here because I don't even have a middle letter in here to tell me what that would be, okay? So if I'm looking at these two, looking at this picture is given, okay, here's the information given. Angle 1 is 8x minus 6. Angle BAD, which is the whole angle, is 20 degrees. Is 20 degrees, okay? Angle 2 is 2x plus 1. You are to find the measure of angle 2, okay? So what we have is angle 1 plus angle 2 is equal to the whole 20 degrees, right? Angle 1 plus angle 2 equals the whole 20 degrees. So angle 1 is 8x minus 6 plus angle 2, which is 2x plus 11, equals the whole 20 degrees. So we do our algebra, join our like terms together. We get 10x, okay? 10x, negative 6 and 11 is 5. 10x plus 5 equals 20. 10x equals 15. X equals 1.5. We are not done because what we were asked to find was angle 2. So we go back to angle 2, which is 2x plus 11. But now we have the x value. which is 1.5, which of course there's 2 times 1.5 for 3 plus 11. So angle 2 is 14 degrees. And since the entire uh, BAD angle is 20, that would make angle 1 6 degrees. Okay? Coming here again, we got angle BAD. BAD is the all-inclusive. I put that out there as 11x minus 6. That's the all-inclusive. Okay? Angle 1 is 5x plus 6. Angle 1 is 5x plus 6. Angle 2 is 3x plus 9. We're asked to find the measure of angle 1. Again, the statement of angle addition would say angle 1 plus angle 2 is equal to the angle BAD. So 5x plus 6 plus 3x plus 9 equals the entire angle, which is 11x minus 6. Okay, make sure you get your equation set up right. Again, it would be probably in our best interest to write our statement of angle addition there. Okay, and in doing that, we would know what to plug in and where to plug it in. So this is what we end up with. Okay, 8x plus 15 equals 11x minus 6. Join your like terms. I chose to bring the 8x over here by subtracting, which would give me 3x. Adding the 6 over here give me 21. Tells me that x is equal to 7. The question I was asked was, what is angle 1? Angle 1 is 5x plus 6. Knowing now what the x value is 7. 7 times 5, 35, plus 6, 41. And that's what we're going to do with our angle addition postulates. Okay? So there you have it.